You wear a watch, you count birthdays, you trust that yesterday is gone and tomorrow is coming. Humans have measured time with sundials, atomic clocks, and pulsars 1,000 light years away. But in the deepest equations physicists actually use to describe reality, one variable keeps vanishing: the variable for time itself. What if the most familiar thing in your life is the biggest lie the universe tells you? What if your future has already happened, and your sense of flow is just a trick? Subscribe and let's walk into 10 things physics knows about time and still cannot explain. In 1967, physicists John Wheeler and Wheeler-DeWitt tried to do something no one had managed: write a single equation that combined Einstein's gravity with quantum mechanics. What they produced is now called the Wheeler-DeWitt equation, and it is one of the most haunting formulas in science. Because when you look at it, something is missing. There is no t. No time variable. At the deepest layer of reality, time simply is not there. It is as if you opened the blueprint of the universe and found no clock at all. Physicists call this the problem of time, and after nearly 60 years, no one has solved it. Some think time is an illusion that emerges from something deeper, like temperature emerges from atoms. And if that is true, the ticking you feel right now was never fundamental. But if time is not real, why do we feel it move? Every time you open Google Maps, you are trusting Einstein. The GPS satellites orbiting above you sit 20,200 kilometers up, moving at about 14,000 kilometers per hour. And because of that speed and altitude, their onboard clocks tick faster than clocks on the ground by exactly 38 microseconds per day. That sounds tiny. It is not. If engineers did not correct for it every single day, GPS positions would drift by about 10 kilometers within 24 hours. Your car would think it was in the next town. Your phone would be useless by lunch. Einstein predicted this in 1915 with general relativity. Time runs slower near mass and slower at high speed. It is not a theory anymore. It is a line item in satellite maintenance. Time is not a universal river. It is a fabric that stretches and shrinks around you. And that means something worse. You never actually see the present. Look up at the sun. You are not seeing the sun as it is. You are seeing it as it was 8 minutes and 20 seconds ago, because that is how long its light takes to reach you. If the sun vanished right now, you would keep feeling its warmth and seeing it in the sky until 8:20 had passed. Look at the moon. You see it 1.3 seconds late. The nearest star, Proxima Centauri, 4.2 years late. The Andromeda Galaxy, 2.5 million years late. Every face you have ever seen, you saw a fraction of a nanosecond after it happened. There is no now for your senses. You live permanently inside a delayed broadcast of the universe. Astronomers call this look-back time. Philosophers call it something worse: proof that the present moment is not something you can ever actually reach. And it gets stranger, because Einstein showed the present is not even a single thing. In 1905, a 26-year-old patent clerk named Albert Einstein published a paper that quietly destroyed the idea of a shared present. In special relativity, two events that look simultaneous to you can happen in a different order for someone moving past you. Not by illusion, actually. If you and an astronaut flying at high speed both watch two lightning bolts strike, you might see them hit at the same instant. She might see one strike first. Neither of you is wrong. There is no universal now. There is no cosmic tick that the whole universe shares. Every observer carries their own slice of time, tilted at their own angle through space-time. Which means when you ask what is happening on a planet in the Andromeda Galaxy right now, the question has no single answer. And if there is no shared present, maybe past, present, and future all exist at once. This is a theory, not a proven fact, but the physicists who take it seriously are not joking. It is called the block universe. In this view, space-time is not a river flowing forward. It is a solid, four-dimensional block already complete. Your birth is at one end. Your death is at another. Every breakfast you will ever eat, every word you will ever say, already there, already fixed, like frames in a film reel that has already been shot. Einstein himself, writing to the family of a friend who had died, called the distinction between past, present and future a stubbornly persistent illusion. In the block universe, nothing flows. You do not move through time. You are a worm-shaped object stretched across it, and consciousness just lights up one slice at a time. If this is right, your future self is already out there, waiting, frozen in the block, and you cannot change a single frame. Here is something no physicist has ever properly explained. Take almost every fundamental law of physics, Newton's, Einstein's, quantum mechanics, and run them backwards in time. They still work. Nothing in the equation says time must flow forward. And yet it does. Coffee cools, it never spontaneously reheats. Eggs break, they never unbreak. Stars burn out, they never rekindle. We only ever remember the past, never the future. The one clue we have is entropy, the tendency of ordered things to fall apart, described in the second law of thermodynamics. The universe started in an extraordinarily low entropy state at the Big Bang, and it has been unraveling ever since. Time in this view is just the direction in which disorder increases. But why did the universe start so orderly in the first place? No one knows. The arrow of time is pointing somewhere, and physics still cannot tell us why. About 13.8 billion years ago, according to our best measurements from the Planck satellite in 2013, everything you have ever known began. Space, matter, energy, and time itself. That is the part people find hardest. Time did not exist before the Big Bang because there was no before. Stephen Hawking put it this way: asking what came before the Big Bang is like asking what is north of the North Pole. The question has words in it, but it does not mean anything. Time is a feature of our universe, not a stage on which our universe sits. And if that is true, it also means time might have a shape. It might be finite. It might loop. It might end. Somewhere in the first instant, in a period lasting less than a trillionth of a second, the rules we know took hold. And what came before those rules is not just unknown, it may be unaskable. This next one sounds like pure science fiction, but it comes straight from Einstein's own equations. In 1949, the logician Kurt Gödel, a close friend of Einstein, found a solution to general relativity in which time bends so severely that a path through space-time can loop back into its own past. Physicists call these closed time-like curves. On such a path, if you followed it long enough, you would return not just to the same place, but to the same moment. Later solutions found similar loops around rapidly rotating black holes and around theoretical objects called cosmic strings. Now, no one has ever built such a loop. Most physicists suspect the universe forbids them somehow through what Hawking called a chronology protection conjecture. But the equations do not forbid them. Einstein's own math says time travel to the past is not impossible, only, perhaps, impossibly hard. And time gets stranger still. In 2012, Nobel laureate Frank Wilczek proposed something that sounded impossible: a crystal that repeats in time instead of in space. A regular crystal, like salt or diamond, has atoms arranged in a repeating pattern across space. A time crystal would have a pattern that repeats over and over in time, forever, without ever using energy. It should have violated the laws of thermodynamics. It should have been impossible. In 2016 and 2017, two independent teams, one at the University of Maryland, one at Harvard, built them. The results were published in Nature. Time crystals are real. They are a genuine new phase of matter, ticking eternally in the ground state, needing no fuel, breaking a symmetry of time itself. We do not fully understand why they work. We do not know what they can do. But somewhere in a lab right now, a chunk of matter is quietly beating like a heart that never stops. And it will still be ticking long after we are gone. And here is the fact that haunts cosmologists most: time may end. In roughly 10 to the 100 years, a Google years from now, the universe will have finished dying. The last stars will have burned out. Black holes will have evaporated through Hawking radiation. Every particle will drift alone in a cold, expanding void. And in this final state, called heat death, something terrifying happens to time itself. With no change, no motion, no difference between one moment and the next, physicists ask whether time has any meaning at all. If entropy is what defines the direction of time, and entropy has reached its maximum, then there is no arrow, no tick, no later. The physicist Roger Penrose has even suggested that at this point, the universe forgets scale entirely, and its end becomes indistinguishable from a new beginning. This is our cosmic fate. Not an explosion, not fire, just a slow silence in which the word later stops, meaning anything at all. Time, the thing you trust most, may simply run out of things to do. Time is the closest thing to you. It is on your wrist, in your body, in every heartbeat. And yet it is the thing physics understands least. It may not exist in the deepest equations. It does not flow the same for any two people. It has a beginning we cannot ask before. It may have an end after which later has no meaning. And every future you dream of may already be waiting, frozen, in a block you cannot see. So tell me in the comments, do you believe time is real, or is it the greatest illusion the universe has ever pulled on us? And which fact scared you the most?